All right, this is the Algebra 1, Unit 3, Lesson 6 video over what we call compound inequalities. So what a compound inequality is when we have a relationship where instead of it being something like, x is greater than a single individual number, like we've been working with so far, like x is greater than 4, if we look at that on the number line, six. All right. So like in this example, we know that the solution is going to be open circle at 4 and greater than 4. So that's just a simple inequality. It's just one number and x is either above or below that number. So for a compound inequality, we have more than one relationship working together to form a particular relationship. So we might say x is less than or equal to 2, or x is greater than 4. So in that situation, if we put those together on a number line, and I graph the values and I say, okay, x is less than or equal to 2. So that's a closed circle at 2 and going this way. Or x is greater than 4. Well, that's going to be an open circle at 4 and shading this way. So you can see in this, there are two areas of the graph where x could be. X could be in the area over here below 2, or it could be in the area here above 4. So that would be what we call a disjunction, which is to say that x can appear in either part of that graph, either part of that number line. So that's a disjunction. Okay, so this is an example. I'll just write this down here. Disjunction. Now, on the other side, we have what we call a conjunction. So a conjunction is when we say something like this. We say x is less than 3 and x is greater than or equal to negative 2. And when we look at those together, what we find out is that if I were to combine these statements and I put x here, I know that x is less than 3, but x is also greater than or equal to negative 2. This can be combined into a single statement. And that single statement is what we call a conjunction. It's the joining together of those two statements into one. And so that looks different on our number line. If I graph this on a number line, I'll see that so we have 0 here, 1, 2, 3, 4, 5. Let's put some numbers over here. So if I graph this, I'm going to find that we have negative 2 is going to have a closed circle because x is greater than or equal to that, but it's less than 3. So what ends up happening is those two graphs end up kind of joining together and showing that x actually appears in between those two numbers. And so that's what we call a conjunction. And so really you're going to be working with one of these types of compound inequalities in our lesson. But first, we're going to go through some examples like the ones in the lesson where you have to solve a little bit more complex inequalities that take extra steps, like not just a single step or maybe 2 steps. Some of them are going to take more than that. So I'm just going to work through examples. I've modeled these on the ones that you see in your lesson. So you'll need to work those on a separate sheet of paper. But I'm just going to talk us through. So again, like I've said in the past, there's really no big difference between solving inequalities and solving equations, except you have to remember the rule about negatives. And it is, if you remember, it's that when you divide by a negative, switch the sign. Again, this would become this, right? As an example, switch the sign. So that's what we're doing when we talk about switching the sign when you divide by negative. So we'll actually see an example of that here in the first problem. So in order to solve this, I need to get the x's together. So I'm going to move the 7x. That's going to cancel out. 4 minus 7 is negative 3x equals 12. Oh, no, negative 12. A mistake there, because that negative sign there is going to come down. And then I'm going to, and I put an equal sign. I'm making all sorts of mistakes this morning. All right. Now, in my next step, I'm going to divide both sides by negative 3. So when I do that, this is going to switch based on our divide by negative rule. So my answer, the 3's are going to cancel out, leaving me with x. And then when I switch that sign, it becomes less than. Negative 12 divided by negative 3 is 4. And so that would be my solution. And then if I were to graph that on the number line, I don't think you need me to do that again for you. You've seen a lot of those examples. You would just graph that on the number line that's provided. But that is the solution. And that's more or less what you're doing here. We're just solving. So I'm going to do more examples, and then we'll look at some compound inequalities. All right, so in this problem, we have a distribution that we need to do first over here. So we're just going to rewrite this. 3 over 2x minus 2 is less than or equal to 4x minus 12. 4 times x is 4x. 4 times 3 is 12. All right, well, I need to move this 2 over, leaving me with 3 over 2x is less than or equal to, that's going to cancel, 4x minus 10. At this point, you can move the 4 across, but I would actually recommend that we get rid of this fraction, and we can do that by multiplying times 2, which means I'm going to multiply everything times 2, each term. So let's see what we get. We get 3x is less than or equal to 8x minus 20. So let's bring this up here, and let's keep working this. 3x less than or equal to 8x minus 20. Now I'm ready to move my 8. I can subtract 8x from both sides, canceling that out, leaving me with negative 5x is less than or equal to negative 20. Now I'm going to divide to get rid of that negative 5 on my x and get x by itself. When I divide by a negative, I remembered I need to switch the sign. So that becomes greater than or equal to, the 5's cancel out, x is greater than or equal to negative 20 divided by negative 5 is a 4. So x is greater than or equal to 4. All right, so those are just some inequalities that take extra steps, very much like the ones you're going to see in the lesson. Then they have us do combinations. So with the combinations, you basically need to, what I would say is go ahead and draw your number line. And let's go ahead and graph these two on the number line and see what we come up with. So if it says x is less than 4, so 4 is going to have an open circle, and it's going to be less than. But it also says x is greater than or equal to negative 2. So we're going to have a closed circle at negative 2. And we're going to see that these are going to join up. So this is a conjunction. So what this tells me is that I'm going to have an expression with x in the middle. And then I need to place the numbers where they go. Well, 4 is higher than x, and negative 2 is lower than x. And the symbol with the negative 2 is like this. And the symbol with the 4 is like this. And you'll notice this ended up switching when I brought it down here, but that's because I'm also switching where the x and the negative 2 are located. But when you're done, you should have an expression like this. And your inequality symbols should always point down. So they should be pointing towards the lower end. So that's why when I switch my negative 2, it ends up with a less than rather than a greater than. So that's what it means when it says combine. And here's another one. Now this is an or, so this is a disjunction. So I need to actually solve these, and that's kind of the unique thing about this is I've got this equation here is not ready, but if I bring it down and I solve for x, I can add 2 to both sides. And the final kind of expression is x is less than or equal to negative 4. Or, notice it's an or. It's a weird R. Or, bring that down. This one, I could just solve this one really easily. Divide both sides by 2. X is greater than 0. So now we look and we go ahead and graph these. So we're going to get our number line down. All right. And then let's go ahead and graph. So I have a -4. It's going to be a closed circle at -4, and it goes less than that, so it's shaded down this way. And it's greater than 0, open circle, and it's shaded up this way. So this is a disjunction. And we knew that because of the or. So the or is going to go like this, right? Whereas the and is going to be like the one we had above, where we have and it's going to be in between. So or is going to always give you this kind of look. Now this one, we actually have to solve two different expressions. We're going to solve an expression that is here, so as you see, surrounded by the pink, and then we'll have another expression here surrounded by the orange. So it's a little bit weird, but let's see. So if I bring down what's inside the orange, I get an expression like this. If I bring down what's inside the pink, I get one like this. And so really, I'm just solving each of those and then combining them after I'm done. So let's work out this one. I'm going to subtract 3 from both sides. Okay, and then I'm going to divide by 2, and I get x over here with the greater than or less than symbol with a -4 over here. Okay. So in this case, if I really wanted to rewrite this, and I think it's nice to, I'm going to put it like this. Notice I switched everything. I just reversed the expression. And then we move over here. I'm going to subtract 3 as well. Notice you're going to do the same steps because you have the same basic equation. That becomes 6, divide by 2, and it gives me x. Oops. X is less than or equal to 3. So now we have to try to combine these. If I put x in the middle, x is less than or equal to 3, but it's also greater than -4. And then I can graph that on a number line. So I have a -4. Let's see right here, open circle, and I have a 3 with a closed circle, and the x is in between them. So that would be my shaded area right there. And that's the solution. So use those to go ahead and do the ones and kind of follow along and look at the examples that I've done here. All right. After this, we'll be testing next week. So please reach out to me if you have questions. But that is it for our lesson 6 of Algebra 1, Unit 3.